Good morning, afternoon, or evening, and thank you for joining our webinar, Powering the Edge, IoT Analytics and Artificial Intelligence for Smart Metering. I'm your moderator, Idan Kabachnik. I serve as the Vice President of Product Management at Guavus, a leading provider of big data analytics for the telecommunications sector. Guavus is part of Thales, a global leader in advanced technology and digital innovation in areas such as connectivity, big data, AI, cybersecurity, quantum computing, and of course, the Internet of Things, which brings me to today's topic. The $1.2 trillion bipartisan infrastructure bill passed by the US Senate in early August and currently in process in the US House of Representatives includes the single largest electric vehicle infrastructure investment in history, aiming to build 500,000 EV chargers across the United States. Also included are substantial power infrastructure improvements that include thousands of miles of new resilient transmission lines to facilitate the expansion of renewable energy, as well as the additional infrastructure investments aimed at protecting against cyber attacks and extreme weather events. Simultaneously, smart metering deployments are on the rise. We're seeing an unprecedented amount of data from millions of industrial IoT devices. Analysts are already predicting that the industrial IoT will eventually generate more data than there is storage capacity on the planet. Because of this, analytics and AI must be performed at the edge and in real time to meet the needs of critical infrastructure. And to ensure security, the data generated and analyzed at the edge and sent to the cloud must be protected to maintain the integrity of the grid. We've assembled a panel of experts to discuss the challenges, opportunities, technology, and of course, analytics that will make all of this possible. Katerina Dubrovna is an ABI research analyst for the machine-to-machine Internet of Things and industrial Internet of Things markets. Katerina conducts market vertical-specific analytics and competitive analysis of the M2M and IoT market players, technologies, and data-enabled ecosystem. Her current specialization covers IoT data-enabled technologies, including data management, analytics, ML, and AI services, hyperscalers, and cloud computing as well. Her corporate experience includes Ernst & Young as a research analyst for the energy and ICT markets, and a position in NATO as a strategic analyst. Adarsh Krishnan, research director at ABI Research, orchestrates research regarding the Internet of Everything, enterprise, and machine-to-machine markets. Since 2012, he's contributed to extending ABI Research coverage of broadband access technologies, smart home, wireless connectivity, and other emerging transformative technologies. Adarsh has focused on key research and analysis of the Internet of Everything value chain to provide crucial trends in key vertical Internet of Things markets. He's done extensive research on smart buildings, smart grids, smart street lighting, asset tracking, and low power wide area network connectivity technologies. Francis D'Souza is the Vice President of Strategy and Marketing for Analytics and IoT Solutions at Thales. That business line supports customers in critical area sectors such as energy, healthcare, and manufacturing by leveraging Thales's market-leading cellular communication, security, and analyst technologies, as well as expertise to implement successful digital transformation strategies. Francis is engaged with utilities and both head-end system and smart meter vendors around the world, helping implement strategies on investment and minimizing total cost of ownership. With a strong telecom engineering background, Francis has worked with Siemens, Gemalto, and Thales in telco, IoT, cybersecurity, and AI, serving in a variety of roles in sales, product marketing, and business strategy, and all of that in Mumbai, London, and Paris. As the CTO at Guavus, Chris Nightingale is responsible for defining and driving the company's technology roadmap and customer engagement strategy. He leads internal development, external partnerships, and multi-vendor solutions to leverage the power of distributed data analytics. Prior to Guavus, Chris was the executive director of services architecture at Verizon, where he used emerging technologies and network intelligence to build architectures that enabled new business opportunities and created new sources of revenue. Dan Robertson has the global responsibility for IoT and LTE strategy at Landys+Gyr. He has over 30 years of experience in consulting, business strategy, digital transformation, and innovation at leading technology and telecom vendors, solution providers, and carriers. In IoT and mobility, he has worked at Ericsson, Huawei, Sony, Sierra Wireless, Verizon, and Telefonica. In utilities, manufacturing, and aerospace, he's worked at both Panasonic and Landys+Gyr. Dan earned a master's degree in science in engineering from the University of Oxford. Katerina and Adarsh have a presentation for us covering a market perspective on real-time analytics and smart grid. If all other panelists could turn off their cameras so they could share their presentation, that'd be perfect. Take it away, Katerina and Adarsh.
Thank you, Aidan. Thank you, everyone, for joining us today. We will be co-presenting this presentation. I hope everyone can see it. And we will be giving you an overview on analytics and utilities market and how those two converge and what we expect to see in this market in the future. So starting with evolution of the grid infrastructure, for the past decade or so, we've been experiencing a massive uptake in demand for smart vehicles, smart appliances, smart cities, all sort of different infrastructure that is connected to grid. What is interesting that the legacy grid and the previous utilities infrastructure were actually never equipped for this type of rising demand and for the smart component that is happening right now. Only back in 2018, globally utilities spent more than 14 billion to modernize and build smart infrastructure as a part of the digitalization effort for the smart grid, where IoT and AI technology enabled energy suppliers and consumers to have efficient tools to monitor and regulate electric grid performance. So modernizing the grid to make it smarter and more resilient to, for example, power outages and reduce storm impact, or even restore services faster when outages happen. So apart from all of those advantages, what is actually driving digitalization of the utilities market? Well, first of all, it's always cost. So optimization, increasing predictability and efficiency for production and transmission, flexibility and monitoring of assets and equipment, but also management of the energy distribution and various distribution capabilities. So all in all, we see a growing data-enabled oriented technology, especially analytics and advanced analytics in this market that are emerging for enterprises. And I will give the floor to Adarsh now, who will be talking more on trend for sensorization and for smart meter installation base and how there is much more data coming in from all of those installations. Adarsh?
Thanks, Kate. I'd like to maybe just go through two of the slides that are actually in this presentation. So I'll go quickly and hand this over back to Kate. So in this slide, what we're looking at is I would like to maybe just touch upon like the smart meter installations that have taken place so far globally. So far in 2020, we estimate there were over 700 million smart meters installed, and our forecasts indicate that by the end of 2026, we'll exceed over 1 billion smart meters, smart electricity meters installed globally. When you look at it regionally, the smart meter installations, while it started off in Europe, like in Italy, where we saw much higher penetration of smart meters, we are starting to see penetration rates almost like say over 70% in North America, especially in the US, and also in countries like Spain, Sweden, and also in other European countries like the UK, France, and Netherlands that have started like say ramping up their smart metering infrastructure or smart metering rollouts. If you look at the globally, the Asia Pacific region has the largest total addressable market in terms of metering points, and we see that that growth has been picking up in the last decade, especially with penetration rates growing in the East Asian countries like South Korea, Japan, but also in China, which has like the largest install base of smart meters today. Apart from some of the countries that have already implemented large smart metering programs, we're also seeing that growth in terms of smart metering installations pick up in Asia, with countries like India driving growth with an estimated 250 million meters coming online by the end of this decade. In this slide, I want to also maybe touch upon the impact of COVID-19 pandemic on the smart metering rollouts. While we've seen fairly good uptake of smart metering infrastructure by the utilities globally, the COVID-19 pandemic has seen the implementation kind of take a back step or slow down in the last 18 months. We've seen this especially in the North American and the European markets, where we are starting to see maybe a somewhat slow uptake in smart metering rollouts in 2021. But we believe smart metering shipments will only reach pre-COVID levels by early 2023. That said, while the pandemic has slowed down utilities rollout, smart metering rollouts, it has also sort of reinforced the need and the benefit for smart meters and how it adds further more resilience to the utilities distribution grid. In regions where also where we've seen smart meter penetrations reach much more maturity. We've also seen utilities start to invest more in data analytics, and that is also starting to pick up over the years. And as they start to leverage and monetize the data coming from their metering infrastructure, we're starting to see, at least in early stages, we saw the analytics being mostly used for a lot of meter to cash applications. But what we're starting to see now is that's expanding to other utilities operations, early stages, like early implementation starting in, like, say, field services, some loan management, and also supporting new applications such as distributed energy resources and also electric vehicles. And with that, I'll hand the presentation back to Kate so that you can delve a little bit more into the analytics aspects of the utilities infrastructure. Back to you, Kate.
Thank you, Outage. So just to back up sort of the data when it comes to smart metering and sort of the data analytics services that are happening in that market, you can see in the diagram that we actually estimate to have a very steady growth at about 10% CAGR for the data analytics services revenue for smart metering. But if we will talk about utilities as an industry overall, this will definitely exceed this 10% CAGR due to not just due to growing amount of smart metering and all the data is coming in, but also due to more electric vehicles, sensors, smart devices, and other applications that are driving this need for more analytics and for more prediction. If we thinking about IoT analytics in general as a market, in the table below, you can see ABI's estimation for the growth, where we separate analytics and visualization revenue from data management services revenue. So with data management, it's so much more about integration, streaming of the data, and storage revenues included there as well. So this market is currently estimated at 7.5 billion and is expected to grow up to 27. Streaming analytics is being one of the most used real-time tools for utilities markets, so it will be having a great share in there. Whereas analytics and visualization revenues, so will grow from 12 billion up to almost 40 billion by 2026. So I already explained a little bit of our separation when we look at the analytics as a market, and in this diagram you can see sort of the visualization of the value chain when it comes to IoT analytics, where we start from the device or a sensor itself, integrate edge computing, and go into ingestion, sort of integration of the data to the IoT hub, such as IoT Core, for example, or where you can do it with a sort of centralized cloud system. Then you store it and apply very traditional way of applying analytics, where you can do descriptive predictive analysis. Whereas now we see more emerging of streaming analytics and stream processing, which can happen in real time on a continuous amount of stream, which is a very sort of modern way of looking at the analytics, but also the exact one that utilities need to have a closed loop communication and have a real-time feedback on what is happening. So we mentioned quite a bit on sort of the traditional way, which we'd like to view as a cloud-centric or on-prem centric way, where the data is ingested and processed in a one centralized location. However, there is more need now for tracking and collecting quite large data set from, for example, thousands and millions of meters and other smart devices in a real time. And that's where edge-centric technologies and companies are really taking place and increasing their traction. Alongside that, there is emergence of companies sort of in an edge cloud continuum with their softwares and platforms who has this hardware agnostic capabilities as well, that allows quick deployment, but also combination of this traditional and real-time analytics, which can start at the edge and go all the way in the cloud. So to tie it all up a little bit more to utilities and to sort of smart grid as a system overall, Adarsh was already talking about the amount of smart meters that are deployed, but in reality, they sending a lot of very small, but a lot of data points from various places. And traditional analytics is fairly equipped to deal with it. However, it doesn't all happen in real time. And if we're thinking about complexities that are coming in the grid with modernization of it, with intelligent devices and EV charging, or even cameras for further video analytics on site, there is need for more edge compute and more real-time responsiveness, which is not just a simple monitoring or descriptive analytics, but actually analytics that makes predictions and that can deploy ML models, since there is a growing demand for it, as it would help energy companies and vendors to ensure the safety, ensure usability of transition lines, or even predict such things as load for grid for specific times. And therefore, the following slide, we want to showcase a little bit more on different types of analytics and its use in utilities market. And to back it up with some statistics, I said that there's going to be less need for monitoring and for descriptive. However, it's not going anywhere. It's still growing at the steady 16% CAGR, and it would include visualization of metering data, some anomaly detection, equipment monitoring, but we're going to see so much more need and so much more technology emerging, and specifically predictive analytics that will be growing at 29%, where we're going to see use cases of predictive maintenance for a smart grid, but also, for example, prediction for outages, where data from the smart meters, from GPS devices on the trucks or weather station could be combined with real-time data to develop and deployed with the algorithm to have a prediction for restoration time for outages that would drastically improve the information for the energy companies, and that will subsequently improve their communication with their consumers and with their clients. We will also see more on a prescriptive analytics side, which has the highest growth rate at 38%, which is caused predominantly by the fact that since 2018 and earlier, that wasn't the most used type of analytics, but we will see more of it, those type of what-if scenario and proof of concept projects. And one of the interesting use case for utilities would be the usage-based pricing and incentive programs for electricity consumption, which basically is a predictive analytics activity based on different incentive schemes offered and priced, that can be tested for a different price to encourage or discourage utilities consumption. So to finish it all up, we have different types of analytics. Streaming analytics is going to be the next go-to for utilities market. It still has a lot to overcome in terms of challenges. However, streaming analytics and edge analytics would be the next sort of solution for quick data normalization, standardization, cleansing. So when it actually comes in the hub for more advanced analytics, there will be more accessible data and more usable data. On the second sort of part of the story, it will give an opportunity for communicate for the closed loop communication, where the actions can be done based on real time. All in all, to summarize utilities and analytics markets together, I think it's fair to say that utilities are sitting literally on a gold mine of opportunities when it comes to data analytics, as they have a lot of historical, a lot of conventional source data, and now there is a need and possibility to combine this information coming from meters and from other smart devices to really have opportunity to improve reliability and reduce cost, as well as on consumer side, enhance the customer experience and customer expectations from the service. There are different players in the market who, some of them offer more traditional off-the-shelf tools. Some are coming with more specialized software for either production, transmission, or consumer side. And it's still a very early onset to deploy analytics for the utilities markets. And we will see a lot more companies like Guavus who will be bringing more solutions to tackle those challenges. Thank you.
Thank you, Katerina and Adarsh. Thank you so much for sharing that presentation with us. I would ask all of the panelists to turn their cameras back on so we can have a lively discussion. Here's my first question, and Francis, it's for you. Conventional energy generation via hydroelectric dams, large-scale solar power stations, as well as coal-fired gas and nuclear power plants are all centralized. They require transmission of electricity over long distances. But in contrast, distributed energy generation systems typically use renewable sources like small-scale hydroelectric, biomass, biogas, solar, wind, and geothermal, right? So one of the major issues with the integration of distributed energy generation is the uncertain nature of their availability, making the supply-demand relationship a little bit more complex. And managing this complexity requires sophisticated optimization tools to balance the energy network. So what capabilities does Thales offer to make this possible?
It's a good question. I think that's one of the biggest challenges as we're moving from a centralized power generation and distribution to a more distributed architecture with renewable sources, etc., which is driving in a certain way the increase in smart metering rollouts as well. Others mentioned about going from 700 million to 1 billion within the next 4 or 5 years. You've got all these EV chargers as well that are rolling out. And the big challenge in this is demand and supply, balancing demand and supply when both of them might fluctuate over time. So Thales' solutions go into 3 broad categories. The first is to be able to balance the demand and supply, you need to know what's happening. So to know what's happening, you need communication technology. So Thales provides the cellular modules that would help these devices, be they smart meters, be they transmission assets, be they EV chargers, connect over LP-WAN, Cat-M, Cat-NB, or even 5G networks. This is one. The second thing, and this is very important for utilities especially, is unlike other IoT devices, these are long life devices and the total cost of ownership is very important. And things like smart meters are fixed. So the network needs to come to the meter. It needs to be able to fall back in case the base station goes down to another network, etc. Thales helps this with eSIM technology, some of the world leading technology. So that's the communication part, cellular modules, eSIM technology. Now that everything is connected, a utility can get data, a utility can send commands, but if the whole system is not protected, so can someone else. And hacker would love to get their hands on things like this. So therefore, for different types of assets, Thales has cybersecurity solutions, like the trusted key manager for those millions of smart meters to ensure that they're cyber secure across their lifetime. Thales also has solutions like cybersecurity operating centers, where you use analytics and events to be able to detect anything going on. So that's the second bucket. The first bucket is communication solutions. Second bucket, security solutions. And the third one, I mean, you're connecting all these assets, you're getting data, but the data is only useful if you analyze it and do something with it. And that goes back to what Katrina said, where you need streaming analytics, you need predictive and prescriptive analytics, and Thales has solutions in this domain as well, some of the world-leading ones, and I'm sure Chris would have things to add to that as well.
Well, let me jump onto that then. So, I think what you said is like an important part of balancing the supply and demand relationship is, that smart meter, and we're getting into this world with now hundreds of millions and eventually billions of smart meters, each passing kilobytes of usage information every day. So if we think about that, the energy sector is going to need to ingest, process, and run complex analytics over terabytes, if not petabytes of data. And that's really no small feat. So what technologies does Thales have to offer to make this happen? And I'll direct that to you, Chris.
Yeah, so thanks, Adan. I think you mentioned this early on in your introduction. I think Katrina mentioned it as well. Is the volume of the data, is huge. I think you mentioned there's more IoT data in the world than there's storage in the world in your opening. So the ability to deal with these huge amounts of data at the edge, streaming in real time, and be able to only send the information instead of all the data across the network is very important. So Thales has invested in a product called SQL Stream, which is state-of-the-art, purpose-built for streaming analytics. It functions in a centralized and a distributed mode, so that you can put the data collection and processing near the data generation itself, or as near that makes sense for the use case. So what we do is we're able to collect data from many different sources, analyze it in real time to create low latency decision-making functions, as well as historical data that can be used for the prescriptive and predictive maintenance or analytics events. So the SQL Stream technology enables us to collect efficiently, analyze in real time, and deploy machine learning algorithms as well on the edge to support these use cases.
So what I'd like to do is direct it to Dan now. So this category is like analytics for smart meters. So once this data processing infrastructure that allows the efficient ingestion, preparation, and analysis of data is in place, think of that maybe as the canvas, right? The domain-specific analytics, the machine learning processes, the artificial intelligence algorithms become the work of art that goes on that canvas. And these are the solutions to real-world problems. And I know that Landys+Gyr is in the business of building those solutions. And maybe, Dan, you could just tell us about them and the underlying analytics that power them.
Thanks for that question, Idan. Yes, as you say, Landys+Gyr is investing heavily in advanced analytics, and as you say, including machine learning and AI. So our next generation smart meter solution is called Revelo. It's been announced, it's been released, it's been heavily sold actually. It offers this advanced real-time sensing and data processing required for AI and ML. It's supported by an application enablement framework to allow you to download applications that can do quite a lot of intelligent decision making actually at the meter. But also another significant part of the AI ML solution is an integration into what we call meter to cloud. So we have a publicly announced exclusive deal with Google Cloud Platform. So a lot of the more sophisticated AI ML analytics is done on Google Cloud, leveraging their very wide cloud-based capability. What this all means is we can bring a lot of the things that Chris says in terms of what we're trying to achieve into a more consumable form factor. So hopefully that answers your question.
It does, and there's a question from the audience that's related, so I'm going to throw it out at you at this moment. It's fun, all right? And the question goes as follows: do you think analytics for the smart grid will have to be integrated inside of the device management system or the NMS, or will this be a separate analytics layer? What's your view on that?
Well, that's quite a big topic, actually. We actually have a model called layered intelligence. One of the points that we made earlier is there's more actual data than there is storage. So putting everything in the cloud or putting everything in the meter is problematic. What layered intelligence does, it allows you to it gives you distributed cloud, basically. So processing at the meter, processing the network edge, called MEC. I think some people might be familiar with that, but also in the centralized cloud as well. So that gives us quite a lot of sophistication and flexibility to be able to do the processing where it needs to be. And that also maps quite well to grid infrastructure, which is what our business is.
Thank you, Dan. All right, I'd like to tell a little anecdotal story now about my own personal experience to keep this interesting. So I live in the East Bay of the San Francisco Bay Area. Maybe there's some other people, attendees on the webinar today who also live near me. And one of the major changes we've noticed over the past few years is the rise of hot, dry, high wind, firestorm conditions, especially in the late summer, like this time of year. As a result, the local utility, Pacific Gas and Electric, PG&E, I'll call it, they now proactively shut down power through a process known as a PSPS, or a public safety power shutoff. And the problem is the PSPS is a bit of a blunt instrument, shutting down a large swath of power delivery in response to a possible event. And I'll direct this to Francis at first, maybe to talk about the comm side of it. But how can a smarter grid reduce the impact of PSPS events?
So I think your use of the word blunt is probably an understatement. I'd probably say it's more like a bazooka, using a bazooka to kill a fly. So in fact, there's a lot of sensors used all across the grid. I mean, you have the meters themselves, but also sensors that are used all over that are constantly capturing conditions on the grid. For example, you have phasor measurement units that actually can detect within seconds a downed transmission line even before it hits the ground. So you've got those kind of technologies, sensors out there all over. The challenge, though, is being able to capture that data from these sensors, processing it, and being able to make a reaction, if need be, in real time. And this reaction and quick reaction is that you're able to do it, especially with 5G networks and time-sensitive networks. You'll be able to get the quick reaction. But you need to have the granularity and the decision-making rapidly enough to decide to go back to what you said. I mean, are we shutting off an entire area? Is it just a substation, or are there certain points that need to be handled? And that's where you need to be able to capture the data to begin with, but then you need to have strong enough analytics that are doing it based on events in real time to be able to inform the decision-making engine as to what is the action that has to be carried out. And then it needs to go back over a resilient communication link to carry out the decision. Or you could do it right at the edge itself. And that's a question of architecture where Dan mentioned about distributed edge. So it's really going to be about what are you doing it for? Is it for security? Is it for safety? Is it for let's say, consumer incentives? But based on that, you'd need to make a decision and decide where you place your analytics. But the communication part, resilient communication, is the starting point. After that, the data is handed over to Chris and Dan, and they're doing all the cool stuff.
So Chris, you want to add anything on the decision-making side?
Yeah, to add something to that use case. This decision-making is real-time decision-making. We're talking about making a decision in milliseconds. And if you, even if you have the right communication systems, if you don't have the right data architecture, you won't be able to collect the data, process it, figure out that the power line has started to fall, and then 15 minutes later you can say, okay, we figured out that it fell. Well, it's too late. You really have to be able to have a data collection architecture and a stream processing architecture that makes those decisions capable of being millisecond-based decisions. And so that comes in with this, as I mentioned before, the SQL stream architecture and a distributed data collection architecture that allows you to place that decision-making function close to the data itself to support low latency applications like this one. Another thing I'd add is data analytics gives you the ability to look at the network from multiple angles, and the more degrees you look at a problem, the more visibility you have. So being able to look from a sensor, you really basically look out at the network from that one location. If you're looking around the entire problem, you see the issue from hundreds of dimensions, and it allows you to identify the problem quicker and to realize that this is exactly what the problem is. It's much more accurate. So we have an accuracy level that we need to do here with these public safety power shutoffs, as well as a timeliness. And like I said, the blunt instruments used today because a lack of the accuracy and a lack of the timeliness, so they just blunt instrument turn everything off. So analytics and a distributed data collection architecture could significantly improve that localization of that fault.
Let me ask Dan maybe, what other ways can analytics and machine learning and AI help utilities maximize availability, both from a residential delivery point of view, as well as from a transmission over the energy network point of view? Yeah,
that's a good question. Power outages, it sounds like you're obviously suffering from this, is not a good thing. So losing power is not really what you're not a service you expect. So that's probably an expectation that you have reliable service. So first of all, there is a solution for that, apparently, called Advanced Grid Analytics, AGA. But that can be improved. And what we're talking about today is AI and ML. So how do we improve AGA with AI, ML? So AGA today allows you to identify and locate and manage power outages. You could argue it doesn't do it particularly well. So we're looking at how we improve that with new, more advanced analytics. So with AI, ML, with all these sensors that we talked about, with all this data we talked about, should be able or will be able to predict and prevent outages in the first place. That gives you good service, right? It never happens. That's it. Don't even notice it because I actually have good service in California. So that's really what you're looking for. And if you can't do that, the next best thing is rapid service restoration. So if you have a blackout, then let's bring it back online quickly or quickly as possible. So analytics can make the location identification of things like power lines down, intermittent issues related to vegetation management, i.e. a tree touching a power line and potentially starting a fire, as well as taking your power down, which is even worse than losing power. So fire and losing power at the same time is not good. So these are the kind of things that we're looking at, is taking an existing AGA framework and adding AI and ML at various levels to make this a better experience for consumers like yourself. And the public safety thing in California is a real big deal. So these are things that we are looking at, and these are real use cases. So this is what I like about my job, is actually taking technology and solving use cases like that for people like you. So hopefully that answers your question.
Well, thank you, Dan. Let's go to just a slightly tangential area, and this is like electric vehicles, right? So the rise of electric vehicles poses a different challenge for the grid. As that technology gets more and more adoption, the possibility of too many EVs charging at the same time and overloading the supply gets more acute. And how can analytics help with this problem? And what mitigating actions can the smart grid take to address it? Let's send that to you, Francis.
Yep, the rise of EV, especially in places like California. So coupled with your weather changing patterns, you've also got all those EVs connecting in. And in fact, layered with that is also an additional thing on the supply side, which is distributed energy resources, right? So you've got solar panels and turbine generating energy, but intermittent at times based on natural resources. And you've got all these EVs also plugging in. And this balancing this is today, I mean, utilities are grappling with this problem, especially in California. So today, the answer to that is being deployed is kind of mass instruments like time of use. So everybody's incentivized to kind of charge during the night, for example, when the overall load is down, and that's what's happening. But that's probably not efficient, because that is not efficient, in fact, because what if people have different patterns? They're driving an electric vehicle, but it could be an emergency worker that is on nighttime duty, etc., and therefore charges during the day. And then how are you going to handle those kind of situations? So and then linked to this balancing the grid, there's an additional capability that's coming about, which is called automated demand response. So for example, the utility is able to tell those Teslas or EVs that are charging to stop charging at a particular time, because let's say the supply is not good enough. So you have this automated demand response coming in. But now the automated demand response has to be good enough to be able to ensure that it's the EV that's being turned off and not the heating in the middle of a snowstorm, right? And of course, this automated demand response is with customer consent and all of that. So that's all perfect. But how do you get that granularity to be able to decide what to turn off, when to turn off, where to turn off? And that's really the challenge, where the EVs can be handled with automated demand response, but the automated demand response can be effective if you've got as good enough analytics to decide what, where, and when to turn off. That's a really important point.
So Francis, you've made me think of something. So like last week, and this is no joke, I received a letter from the local utility, PG&E, telling me that I was using too much energy. And that due to California state regulations, I was going to be kicked off my electric vehicle rate plan. No longer able to get the benefit you just talked about of less expensive nighttime electricity for charging my EV. Needless to say, I was quite alarmed because not getting that EV rate plan could double, triple, or even quadruple the cost of driving for me. And especially given the various energy pricing rates that are present on my bill. I definitely didn't see that one coming when I purchased my Tesla. And as the old adage says, no good deed goes unpunished. So I called PG&E to figure out what to do. It turns out that their systems can tell me how much energy I use at different times of the day, but it can't tell me which appliances are associated with that consumption. The only thing obvious in their charts was that my Tesla was using a huge amount of energy at night when it charges. Go figure, right? So the only solution I could come up with on my own was to cease driving my Tesla and switch back to my gas vehicle to stay below their threshold, which is not exactly what I think the state of California, the regulators, had in mind when they put me in this predicament. So you gotta love how government works, right? Anyway, I did a little bit of web browsing. I spoke with some of my friends who have EVs, and I decided to buy a Sense monitor. And I paid for my electrician to install it. And it uses analytics, ML, and AI to analyze the changes in my home energy usage pattern and determine which appliances are active and what levels of energy they consume. I've been using it. It's helped me figure out a few things, and I've kind of reduced a little bit, but it's still not great. But I just found out, Dan, that Landys+Gyr actually provides the underlying technology that powers that Sense monitor. Maybe you could tell me about this load disaggregation technology.
I can tell you some things about this. So our Revelo smart meter platform we described earlier is capable of supporting a huge range of applications and use cases. Load disaggregation is obviously one of them. To be able to do that, it's actually quite a complex problem, actually. So what you need is, if we talk about real time, you need very high resolution data processing. You need to be able to monitor supply as well as load, because Sense does that. And then you need to be able to control Sense's control switches or load control switches, which are remotely controlled. So can you do that on our meter? Yes, you can. Do you have the onboard processing to run an application like a load disag application? Yes, you can. You're able to make those complex decisions related to patterns on board and share them with a cloud platform? Yes, you can. What you can expect to see in the future is those kind of consumer-facing applications installed in meters. What this means is it's more convenient. There's less cost involved, if not no cost to the consumer. Or direct cost, it's always a cost, but indirect cost. And in terms of your electrician coming around to install your box, is out of business, right? So once the meter is installed, you have that capability. So load disaggregation is one of the key use cases for Revelo, and there are many other use cases as well. But that's one benefit that we actually have sold to large utilities. So yeah, we can help you out in the future.
All right. Well, I'm already in for a few $100 on the Sense and a couple $100 with the electrician, so maybe I needed your meter sooner.
You've got three choices, and you either go back to driving a gas vehicle, you either buy the wait for the meter or the Sense, or you negotiate a pay rise with HR.
All right, we get a few choices there. You know what? I may bring you into that meeting, Francis. Let's bring Katerina in here. I wanted to ask, so maybe you could help with this general problem. Once you have the load disaggregation data, how can we use that to make a difference in consumption?
Well, it's one of the sort of techniques where AI has almost become normalized, because Dan talked about pattern recognition, which is basically one of the machine learning techniques. It brings the greater awareness for a consumer on their how much they're using, for example, for their heating, for their ventilation, for their air conditioning. It also can be used for commercial buildings, for example, and for even industrial sites. Can reach out consumers with different incomes, for example, to be actually aware consumers who are concerned with sustainability effort. So it has a great application, and even for you, you can fix the case with your Tesla.
So let's also bring in Adarsh here. So everything I shared about my home energy woes really depends on this California demand-based time of day pricing. Is California an outlier, or is this common elsewhere? And is that going to change? Is this going to hit everyone?
this actually, like, say, carried on in 2021. This is, like, say, the most famous thing that happened, like, in 2020. But so I was just saying it, Dan. California is probably one of all the investor-owned utilities, at least in California, are planning to implement like some form of time of use rates. And in the US itself, almost 300 utilities offer at least some form of time varying rate to their residential customers. That said, California is an outlier in the sense that it's perhaps the first to use the time of use rates as a time of use rate plan as a default rate to its customers. Now, will it change? I don't think it's going to change anytime soon. If anything, like all the other utilities will slowly start to migrate and offer the demand-based time of use rates eventually over time. Because there are like say two benefits here, right? Like so from a utility standpoint, utilities greatly benefit from the efficiencies, like say coming from the load shifting, right? And for the consumers, as long as they're actually able to see the kind of energy that they're using, where they're actually using it, and what time they're using it, they might also be able to marginally lower their energy bills as well. So that's like what both of them benefit, like both the utilities and the consumers in the end. Now, is it like say practice elsewhere? Like across the world, utilities are trialing out different forms of time of use implementation. So we have like in South Africa, Eskom trialing at the moment, or even implementing it. In Europe, you have Octopus Energy in Britain that have actually started offering different forms of time of use rates. Also in Asia, you have Korea, KEPCO. In Japan, you have the TEPCO as well offering time of use rate. So if anything, in places where you have seen, or if there's like some sense of there's some rates, some degree of maturity, at least from smart metering rollouts, utilities have started to sort of implement also time of use rates to improve their efficiency with regards to their supply and demand of energy.
Thanks, Outage. There's a question from the audience. So I'm going to throw one at all of you at this moment. The question goes as follows: are there any open source libraries to identify usage patterns or signatures of home electric appliances? And maybe this is best for you, Dan. It sounds almost competitive to what your special magic IP, but is this in the open source?
We invite this actually. So our application enablement platform has a marketplace, and we have a developer community, and we invite open source code as long as it's legal, right, to deploy. We certainly invite that, and we invite developers as well to join our community. So yeah, bring it on as far as I'm concerned.
All right. And Francis, there's another question from the audience I want to direct to you, and that is, what are the typical communication protocols, LTE, SD-WAN, et cetera? What are used between smart meters, edge devices, and so forth?
So generally, smart meters, the first generation smart meters used communication technologies called power line communication, where multiple meters hooked up to a gateway and the gateway out. The newer generation of smart meters, especially with the advent of machine type communication and LPWAN networks, LTE-M and NB-IoT and 5G networks, are moving to what's called P2P, or point-to-point directly connected meters. To a large extent, they're moving that direction because costs are down. You can your architecture and rolling it out is a lot easier. You can just put 1 meter at a time. You don't have to consider gateway, etc. So that's generally moving towards cellular communication in the big way. Then between the meter and the other devices, because that's what you mentioned as well, in the home, you then have a kind of home area network that's created. So this, sometimes you might have communication hubs that have Bluetooth links to connect to other devices like display monitors, etc. You also have Wi-Fi, and I know Landys+Gyr is a big proponent of Wi-Fi as well, that uses technology often for the home area network or the associated devices that are connected to the meter and then backhauls. And I don't know if you want to add something to that, Dan.
Yeah, I think all of the above. Certainly globally, NB-IoT versus Cat-M is one big area of debate, and depending on where our meters are deployed, we go for one or the other. Mesh is evolving, as you say, into Wi-Fi. Wi-Fi is the first global mesh standard. So we're moving away from proprietary mesh solutions, and PLC power lines still exist in some markets. Yeah.
That's right.
And there's another question for the audience that I want to send to you, Chris, and that is, Here's the question. What are the different Thales edge computing solutions? What's the architecture? Maybe you could give us a little bit there.
Well, it's the Thales Edge solution architecture. Again, we talked a little bit about our SQL stream architecture. It is an architecture that allows data applications and analytics applications to be pushed as far as all the way to a meter or in the mobile edge compute, so that those applications, complex applications we're talking about for prediction of load and other things can be aggregated at a mobile edge compute location or all the way down into the meter. So that's the primary architectural solution for to support IoT analytics.
All right, two more. We're getting a great series of questions from the audience. So I really appreciate that. So we're staying off script here, which I like. And the next question is, and I'm not sure which of the panelists want to take it, but I'm sure someone will. In terms of monetization opportunities, how can distribution companies benefit from understanding these consumer appliances? How can they make money based on this? Please, Dan.
Should I have a go at that? There's a couple of models actually. One of them, as I said, in terms of low disaggregation for you don't have to pay for it, but you do have to pay for it, right? So there's always going to be a certain amount of monetization in terms of your billage, shall we call it. So that will cover that service. There are obviously direct subscriptions, opt-in type options as well that you can purchase from an app level if you see the benefit, and there obviously are benefits in terms of that. But I think most of the models are subscriptions. So if you're moving away from a consumer product purchase more towards a subscription model, is what I would say, and that's real, right? Because the solution that I was describing has been sold, and probably one of the biggest announced customers, which is in the public domain, is National Grid in North America. And you mentioned TEPCO. TEPCO is our biggest customer. We have 30 million smart meters under TEPCO, right? So these customers are buying this technology, and they're buying it because it's benefits, but they're buying it because it makes sense financially for them to do it. So rest assured, there are revenue streams there. It's not just a nice to have technology.
And Dan, there's another follow-on audience question I think you can probably hit quickly, and that is, do you need a different meter or a different type of meter depending on the load at the consumer level?
Depends on what you're trying to do. So smart meters today are pretty smart. You can run applications on them. They don't have advanced DSPs, so they can't do the processing. They don't have the real-time and analytics capability. You can't run AI ML directly on them, but we are introducing the cloud to them. So with this generation of meters that we have today, we could do stuff cloud-based, but that does introduce lots of issues in terms of data congestion and things like, and granularity. You mentioned that term as well. Revelo, which is announced and sold, solves all of those problems. So we built that meter to solve the problems we're describing today. So we can do a certain amount in existing meters, but Revelo is basically the Nirvana, I would say, in terms of this problem.
Yeah, this discussion made me think of something. It made me think of what happened back in Texas last February. The gas lines and the windmills were frozen due to exceptionally cold temperatures. And that cascaded into an electrical energy shortage, and the real-time supply side pricing, just spiked. I think it was like 1,000-fold. And meaning the people who could get electrical supply were paying $1,000 a day for their electricity. How can analytics help detect, react to, prevent this sort of thing? And maybe I'll send that one to you, Adarsh.
Sure, and this is kind of like something that I can relate to as well. My sister is actually based in Dallas, Texas, and she actually told me once that when this actually happened, she called me up and she said, like, I don't have any electricity, and it's really cold here, and I have like a year-old daughter as well, so we're all actually like say in the bedroom trying to like say stay warm. To understand like say this issue, you also need to understand the Texas power grid and how actually it's powered, right? So if you look at Texas and their power generation, a large part of it is actually dependent on the natural gas infrastructure, and their peak demand, especially when you look at the during winters, much of their winter power capacity, or like almost like about 45 gigawatts of energy, is dependent on the gas infrastructure. You see a lot of those gas-powered plants come into action and then supply the necessary energy for the residential and commercial use cases. And this is not, like, say, limited to just the Texas state itself. In the US alone, there are like over 1,000 peak-up power plants that come into action every time there's like a peak demand. You use fossil fuels to augment their existing energy supply. What's going to happen eventually, this is mostly like because of the climate change and the demand, like say, from consumers to maybe reduce their reliance on fossil fuels. We'll start seeing more of the grid itself becoming more greener. You'll start seeing more of the distributed energy resources coming into play. You'll see more solar PV panels and wind farms and the others starting to augment their existing energy production capabilities. And when this happens, you're starting to see a lot more complexity you're adding a lot more complexity into the grid itself. You're not looking at just energy flowing from production to the consumers or, like, say, to end consumers. You're also seeing, like, say, maybe energy flowing in the other direction from the consumers to the grid. Right? So when this bidirectionality of power happens, we're starting to see a lot more need to manage this more dynamic system, like, say, in the grid. And that is where, like, you'll start seeing a lot more use of analytics, and you really need the data coming from all of these different points to manage the grid more efficiently. So that is where we believe, like, say, AI and analytics will play a really essential role within the utilities operations, not only, like, say, to manage, like, say, the demand supply bit, but also, like, say, when they start implementing or start enabling new applications, right? Like things like electric vehicle charging, for example. As we start seeing more and more of these electric vehicles coming on the roads, we're seeing more demand for energy from the end consumers as well. How efficiently, like, say, can the utilities address the actual demand without having to spend lots of money, again, like, say, in building massive infrastructure and building power plants, for example. That is where, like, say, we believe some of the investments that the utilities are making in both modernization and also in analytics will play a really big role going forward.
Thanks, Adarsh. I have a question from the audience I'd like to direct to Chris, and that is it possible to use these analytic solutions on premise?
Is it possible to use the analytics on premise? Yes. And to what Adarsh said, however, some of the as the grid becomes more and more complex and more distributed, sometimes the analytics needs information from the entire grid to make a good decision. So the issue of analytics on premise is it only has visibility of that premise, right? And so if you're making local decisions based only on that information, it's a terrific place to put the analytics decisions. For some of these more complex, how to balance the the supply and the production when it's a distributed production from thousands of sources, and treating the EVs that are plugged into it essentially as batteries on the network for storage, and how you can do that complex optimization, then a higher level of information aggregation needs to be done. So on-premise, yes, to solve on-premise problems, and then at the higher level when you're really trying to optimize the complexity of this massive complex distributed systems.
All right, I think we have time for one final question and then maybe some closing remarks from each of the panelists. So I'm going to go to the final question, and I'm going to give it to you, Francis. And basically, we're talking about the question that raises the concern of privacy in AI-driven utility service in general. And what mitigating or risk management strategies do service providers currently employ to address these concerns?
So that's a very, very, very good question. And especially with the regulatory framework now, like you've got GDPR in Europe, so utilities have pretty important obligations to live up to when it comes to privacy, etc. And of course, you need to treat data to be able to do analytics. So you need to have the good opt-in, etc. at the start. But the other very important point is the data protection itself. So the utilities employ technologies like HSMs, encryptions to be able to encrypt and protect the data. And the second part is access control of the data itself, as well as to the assets out there in the field. And utilities implement technologies for access control so that only authorized parties can access either the data, and there's a record of who's accessed when, can, for example, access devices, do a firmware update in the device to ensure that nobody's putting in malware when you're updating a device in the field. These kind of mutual authentication and access control techniques are also implemented by utilities. So data protection, access control for the data, for the assets.
All right, let's go to closing remarks. Katerina, I'm gonna let you go first. Any closing remarks that you have for today's wonderful discussion?
Thank you for putting me on a spot.
I like doing that.
Yes. I think just to close up, as I said before, utilities sitting on a real gold mine for analytics opportunities. I think we're going to see so much more, probably in the next sort of 2 to 3 years, more on a device level, and then we're going to go all the way to the cloud. We're going to be talking more on advanced analytics, and there will be time where we're going to be talking advanced analytics in real time. But it's yet to mature. It's a very young market, and it's going to be very interesting to watch.
Oh, looking forward to that. Dan, any closing comments?
Well, me, Dan?
Yeah.
Oh, okay.
Put you on the spot too.
No problem. No, I think I wish we had more time to talk about this. I think the good news is we're actually seeing this right now, and we've closed some significant deals, and they're all around this kind of advanced analytics. It's been a long wait, and we've invested a lot of time and energy into this, but it really is materializing. So it's really good news for everybody, I think. Thank you.
Excellent. Adarsh.
My closing remarks is like, I hope this webinar has kind of given enough some good insights in terms of the utilities market. And often in the past, we've heard utilities are generally considered these very traditional enterprises, mostly like laggards when it comes to new technologies. That's kind of changed over the last decade. I think we've seen a good amount of progress in the utilities adoption of new technologies, and that's going to only accelerate as we start seeing more of these interesting technologies like analytics especially come into play, and as utilities start implementing it, I think it's going to be quite interesting the next few years.
Francis.
So I'm going to take a social angle. I think climate change is probably the biggest issue of our times, and for this generation and the next. And all of the moves by utilities towards clean energy and distributed energy and all is linked into that whole move to a decarbonized economy and for more sustainable future. All of that is only possible if you have extremely resilient communication, if you have the smarts to be able to do stuff on the data, so the analytics, and the fact that you have this whole infrastructure secure. And if you get these three right, I think at least as the energy sector, we'll be doing our bit for combating climate change.
And Chris.
Oh, I'm excited about all these opportunities. It's great to talk to the panelists here. There's just a tremendous future in as Francis said, in clean energy and integration of this, and there's so many opportunities to improve how we deliver power to customers. So very excited about the opportunities.
Well, on behalf of the entire team, I want to thank all the participants, all the audience, everyone who joined in today. This was a wonderful discussion. And there's just two closing thoughts for you. One, you will receive, if you're an attendee, you will receive a recording of this webinar, so you'll be able to play it back again. And two, you will also receive a survey. And we would really appreciate it if you would complete that survey so that we can make this type of presentation even better. I wish all of you a wonderful morning, evening, night, afternoon, wherever you might be, and take care.